So the 3.5 lecture will deal with exponential and logarithmic models. So there are 5 common models that we use: exponential growth, an exponential decay, basically is your b, which would be kind of your the variable in the exponent. But if your exponent is positive, it's showing exponential growth. If it's negative, it's exponential decay. What is called the Gaussian model, the logistic model, and then logarithmic models. You should be comfortable doing that. For instance, this is the form that it takes on the calculator if you do a regression. These two, you just want to be able to work with them and solve for variables within the problem. That's about all you need to know about those. So we can go in and start. For example, a research department had a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 125 fruit flies, and after 4 days, there are 350 fruit flies. How many flies will there be after 6 days? So at the start of the experiment, I'm not sure, maybe use p sub 0 at the 0 mark. I don't know what the population is, but then at the 2-day mark, there were 125 fruit flies. And then at the 4-day mark, there were 350 fruit flies. And they want to know at the 6th day, how many are there? So one of the things that we can do is we can actually calculate the growth rate between here. So let's go ahead and do that. I would say there are 350 fruit flies, but we started with 125. Now R stands for the growth rate, and we're multiplying that by 2. So how do we solve for a variable that's in the exponent? We'd have to divide both sides by 125. Not sure right now what this is. We can just leave it like that. And then now that it's a base sitting there, I can actually ln on both sides, do the natural log. And that, remember, ln of e is 1. So when you bring the exponent down in front, you just have r times 2 on that side, and whatever the ln of 350 divided by 125 is. And then we can divide by 2. So this number right here is the growth rate. And so if we switch over to the calculator, I can go ahead and do my 350 divided by 125. That's 350 divided by 125. It's 2.8. And then we did the logarithm on both sides, so now I can do the natural log of that number. And then we can divide by 2. So it's about a 51% growth rate. So you could multiply that by 100 if you want to get an interest rate or the growth rate percentage, but we don't need it. So now I can pick anything I want. I could do from 2 hours, but let's just go from day 4 to day 6. To calculate the population from day 4 to day 6, I would say it was starting at 350. And this R value, I'm going to take this R value right here and put it in, and that's another 2 days. So on my oh shoot, you didn't see any of that. So I'm going from day 4 to day 6. So I start with 350 E, and I wrote R, but I'm going to use this R value that we just calculated on the calculator and multiply by 2. So we're going to go ahead and do 350 second ln. That gives me E, and it raises it to a power. Now I'm going to hit second negative, and it takes that decimal right above there, and we're going to multiply by 2, and we're going to come up with 980 fruit flies. which would be our final answer. If you go and look at the notes on Moodle, it's done a little bit differently, so pick whichever method you like. They both work. So on this next problem, they're talking about a college campus has 7,500 students. One student returns from vacation with a contagious and long-lasting virus. The spread of the virus is modeled by this equation. So that's one of the models from the very beginning. We don't have to know what it is or what it looks like. We just have to be able to work with it and solve it. Where Y is the number of students infected after T days. The college will cancel classes when 30% or more of the students are infected. So right now it says how many students will be infected after 4 days. All we have to do is take that 4 and put it in for that T and get it to work. So depending on how you want to do this on the calculator, I generally will type it in all at once, so I can take my 7,500 and divide by all of the bottom, which would be 1 plus 7,499. Hit your second ln. Now put the e there, and that's negative 0.9 times the 4 days. So that's what the expression looks like. And after 4 days, there'll be about 36 people that will be sick. So after you plug that in, about 36 students are sick. Now the last one is, after how many days will the college cancel classes? So what we're going to do is they said 30% of the students. So first of all, 0.3 times 7,500. So again, if you use your calculator, 0.3 times is 2,250 students. So what we need to do is set this equation equal to 2250. So we're going to have to multiply both sides by the denominator. So if I multiply both sides by the denominator, basically we'll undo it there and there. And now it's just multiplied over there. So then all right, so now I need to give myself some more room. So now you could distribute the 2250. You can take this and multiply if you want. It's going to be easier for us to just divide by 22.5 on both sides, so 2,250 on both sides. And now you have 1 plus 7,499e to the negative 0.9t. And we could, on our calculator, see if that's a nicer number. So 7,500 divided by 2,250. And it's 3 1/3. So if you want to do it that way, you can. If you hit math, enter, enter, it's kind of a nice way to keep things. So I'll just call it 10/3 then. Now you can subtract 1 on both sides. So I subtracted 1 on both sides, and again on the calculator I can say minus 1, and I get 7/3. Now I need to divide away the 7499. And that will leave me e to the negative 0.9t there. On the calculator, if you take that and you divide by 7499, and that one's a pretty small number, so I'm just going to leave that on the calculator. It's 3.11 e to the negative 4, but remember that's just on the calculator. Oops. So I'm going to leave that, and I'm just making a note that that's on the calculator. So now I can ln both sides. So if I ln, the negative 0.9t comes down in front. Go back to the calculator. Take the ln of that answer. And we're looking at negative 8.07. Again, I'm not writing the whole thing down. I'm not going to write the whole thing down. I know it's on the calculator. And finally, we can divide by negative 0.9. And when we divide that final number by negative 0.9, it's almost 9 days. So they'll have to shut school down in 9 days. All right, example 3 deals with the Richter scale, and kind of an interesting thing when you hear the numbers, like an earthquake that's measured at 4.1 and another one that's at 6.5. It doesn't really give us much of an indicator about which one or how strong the other one was. So there's a formula right here talking about the Richter number is equal to the log base 10 of I divided by I sub 0, where I sub 0 is 1. So the intensity of the earthquake can be calculated. So if somebody tells me for the first one, the 4.1, so this is South Carolina, it was a 4.1 is equal to log base 10 of I, which I don't know how intense it was, divided by I sub 0, which is 1. So we can start this thing off by rewriting it. 10 to the 4.1 is equal to I over 1. Well, I over 1 is just I, so the intensity is 10 raised to the 4.1. And if you go to the calculator, remember, and do 10 raised to the 4.1 power, you get 12,589. And then the other earthquake was in Japan, and that had a 6.5. Again, the intensity divided by I sub 0, which is 1. So now you can 10 to the 6.5. And remember, it's I over, oops, forgot again, sorry. So the Japan earthquake was a 6.5, and it's over 1. And then you take the base is equal to, or being raised, logarithms are always equal to the exponent, so that 6.5 is the exponent. And I over 1 is just I, so all you have to do is calculate it. So I can go 10 raised to the 6.5, and that's 3,162,277. So if I want to compare them, I'm going to put the big number on top and the small number on the bottom when I go to the calculator. So what I can do is take my last answer and divide by the first answer, which was 12589.25412. And when you do that big over small, 3.162 divided by the 12.589, the calculator showed us it was approximately 251 times more intense. And all this is, excuse me, all this is due to the base 10 Richter scale. So when numbers go up by one number, it's 10 times bigger. When they're 2 times bigger, it's 100 times bigger. And if it were 3 numbers bigger, it'd be 1,000 times more. So same thing can be said for the decibel scale. So decibels are units used to compare two logarithmic quantities, particular sounds. Decibels are given by 10 times the log base 10 of I, or I sub 0, where I sub 0 is the intensity of 10 to the negative 2 watts per second meters, or per square meters, roughly the faintest sound that can be heard by the human ear. So I sub 0 is the faintest sound that we can hear. So what is the decibel level of each sound? So how many decibels is a quiet room? Oops, sorry. So decibels will be 10 times the log base 10. And you put I on top, which is the sound you're comparing. So that's 10 to the negative 2. Oops. 10 to the negative 10. And on the bottom, you're putting I sub 0, which is 10 to the negative 12. And so if you can type it into the graphing calculator like that, but when you have an exponent base and the two bases are the same on top, you have something like 10 log base 10, and this ends up being 10 to the negative 10 minus negative 12. And so negative 10 minus negative 12 actually ends up being a positive 2. So now you have 10 logarithm base 10 of 10 squared. Well, log base 10 of 10 squared would leave me with just a 2. So now this is 10 times 2, or 20 decibels. If you went to your calculator and did this, we had the logarithm, which, remember, when you hit the log button, it's base 10 already. And if you type in 10 squared, you get the 2, and then when you multiply by the 10 out front, that's where I got my 20. So a busy street corner is 10 to the negative 5 for its intensity, and 10 to the negative 2 down here. So that'll be 10 log base 10. And again, then you'll have a base 10 here, and you take your negative 5 minus negative 12 would leave me with a positive 7 there. And log base 10 of 10 to the 7th, I call it the chunga property. Whoops. I call it the chunga property, and you're going to just be left with 7. So it ends up being 10 out front and 7 there, so that's 70 decibels. And then pain starts happening with an intensity of 10 to the 0. And 10 log base 10, 10 to the 0 goes on top, 10 to the negative 12 is on the bottom again. And so this is 10 log base 10 of 0 minus negative 2 ends up being 10 to the 12. And again, log base 10, while I'm going to 10 to the second, goes away, so it's 10 times 12, or 120 decibels. So the threshold of pain is something that would register 120 decibels on the Richter scale. All right, so the last problem is talking about kind of using the law of cooling stuff. So you take a 5-pound package of steaks out of a freezer at 11 a.m. and place it in the refrigerator. Will the steaks be thawed in time to be grilled at 6 p.m.? Assume that the refrigerator is 40 degrees and the freezer temperature is 0 degrees. Use the formula. So they kind of give you everything. Where big T, that's the temperature. Big T is the temperature. T is the number of hours. So 11 a.m. until 6 p.m., right? That's 7 hours. So we're going to put in 7. .05 ln t minus 40 over 0 minus 40. So a lot of stuff's done. So now all I have to do is solve for big T in this problem. So I can divide by the negative 5.05. And you can throw that into your calculator. I'm just going to write it. And this turns out to be just negative 40 on the bottom. Now remember, it's base E, so I can go ahead and switch to logarithmic form and take E raised to the 7 divided by negative 5.05 is equal to T minus 40 over negative 40. We can multiply by that negative 40 on both sides. So 5.05, that's 5.05. That's kind of a mess there, 7. And then the last step would be to add 40. So this will get me my big T. So we have to go back now and type in this number, and then we're going to take E and raise it to it and multiply by the negative 40 and then add the 40 at the end and see what we get. So the first thing we did was we had 7 and we divided by the negative 5.05. Then I needed to take E and raise it to that answer. And then we multiplied it by negative 40. And then I had to add the 40. So you can go back and look at the steps, but that's exactly what we did. And so we're getting 29.998, which is 30 degrees. So freezing's at 32, so that technically are showing a frozen temperature, but throw them on the grill anyway.